Okay, so the next quadrilateral we're going to look at, if we follow our parent tree, it's going to have the same properties as a parallelogram. It'll have the same properties as a rhombus and rectangle, and this is going to be our square. So let's open up the book to our properties of a square. So like I showed you on the front, it has all 6 properties of a parallelogram. And then to continue on to that, it had all the properties of a rectangle, meaning it has 4 right angles, so all the angles are 90. And then your diagonals are congruent. So if this diagonal is 10, then that diagonal is 10. So using our other square, we'll go ahead and add those properties in. It has a right angles. And then our diagonals are congruent. Okay. So then the last property, and like I showed you on the front, it has all properties of parallelogram, all the properties of a rectangle. It also has all the properties of a rhombus. To refresh your memory, that means it has 4 congruent sides, meaning all sides are the same. It's a square, that makes sense. Diagonals bisect opposite angles. So remember, if your diagonals bisect the opposite angles, these angles are 90 degrees, right? So if they're 90 degrees, that means that each of those inside of there is going to be 45. So each of them would be 45 degrees if the whole thing is 90. And then your diagonals, I've said before, are perpendicular bisectors. Remember the upside down T? It's math, I like to write shorthand. So perpendicular bisectors, which means that it makes right angles inside of there as well. Okay, so these come in handy. So if we have diagonals that bisect each other, that means they're making 45-degree angles. In the center, it also makes 90-degree angles. And then your diagonals bisect opposite angles, and then we have, the 4 congruent sides. All those sides are together, are the same. And we'll give them 2 hash marks while our diagonals have 2, because they could be different, or they will be different. So let's look at our examples. How can we apply these to find missing sides and angles? So looking at number 1. If BCDE is a square, find each missing measure. So if CF is 8, our diagonals are congruent, right? So if CF is 8, then that means that CE, if this is 8, is 16. It wants to know the measure of BC. So like a rectangle, if all of these are 8, this right here makes an isosceles triangle. So if we have our isosceles triangle, I'm getting into the angles. Doesn't make an isosceles. It makes a right triangle. We want our right triangle. So we can go back like we did with our rectangles and use our Pythagorean theorem to find that missing side. So we could do 8 squared plus 8 squared is equal to x squared. So you do 64 plus 64, and you'd get that when you plug that into the calculator. X is going to be equal to 11.3. Using your Pythagorean theorem, okay, you find that your x is 11.3. So all the sides then are going to be 11.3. Now I was getting ahead of myself with your isosceles, and then the letter C wants to know what's the measure of angle CFD. So now we're looking at this angle right here, CFD. Well, remember, they're perpendicular bisectors, so that angle is 90 degrees. Then it wants to know the measure of angle DBE. So DBE is this angle right here. Well, if they're angle bisectors, so it'd be 90 divided by 2, so this angle is 45 degrees. If we look at number 8, it wants to know if QRST is a square, find QS. So this is the one I was putting the cart before the horse, talking about isosceles triangles. So if we're looking for QS, if this side's 21, then this side is 21. And I guess what we always want to try to do is look for the right triangle. Okay, is there a right triangle that is formed? Here's our right angle. We know two sides. We're trying to find our hypotenuse. So it's going to be 21 squared plus 21 squared is equal to x squared. If you solve that, you get that x is equal to 29.7 centimeters. So that means that QS is equal to 29.7 centimeters.